All right, so here is yet another problem involving Newton's third law and Newton's laws of motion. So here we go. Yes, we're going to have two blocks. Again with the blocks. So here's a block, and let's call this M1, and it has a mass of 2 kilograms. And then there's a rope attached to this guy. All right, and that is attached to the ceiling. And you know, ropes have mass too, but we're going to ignore the mass of the rope. And so then there's a rope tied to the bottom of this block. And that's attached to a second block. Oh boy. And here's M2. And you know what? Let's make M2 have the same mass as M1. So that's also 2 kilograms. And they're hanging there and they're not moving, they're not going anywhere. And so the question is, what's the tension in each of these cables, each of the strings? Well, so again, just like the previous problem where you had 2 blocks and we pretended they were 1 block, we're going to do the same thing here. So we want to find the tension in each rope. So let's call this upper tension T1, and then there's tension in the second rope connecting the 2 blocks. We'll call that T2. So to simplify the problem, let's just pretend these 2 blocks are one big block, right? With the mass equal to the sum of those 2 masses. So we redraw the picture. And there's 1 cable, and now this mass is going to be 2 plus 2, so 4 kg. Now this is much easier, right? There are 2 forces acting on this guy. One of them is this tension, which we said was T1. That's the tension in the rope. The other force acting on this is the force of gravity. That's mg, and it points straight down. And so to find this tension, we're going to write down, you're not going to believe this, Newton's second law. So net force is equal to ma. In this case, because nothing is moving, nothing is accelerating, that makes the acceleration equal to 0 meters per second squared. So if the net force is 0, then how does T1 have to compare to the weight of this thing? Well, they've got to be the same. We could write this out, though, if you're more happy with writing out some equations here, using up as the positive direction. Net force is T minus mg, and that net force is 0. That means that the tension in that rope is the same as the weight of the block. So T equals mg. So plug in some numbers now. So that tension, again, it's T1, 4 kg, times the acceleration of gravity is 10 meters per second squared. 4 times 10 is 40. So the tension in that top rope has got to be 40 newtons. Now, we need to find the tension in the second rope, all right? So let's see, how do we do that? Well, you do that by drawing a picture of the second block. It's also 2 kilograms, right? So again, and I know it's attached to the block on top of it, but let's just draw. So there's the second mass, 2 kilograms. And this tension, that's on the rope that's connecting it to the top block, but we can ignore the top block. So we want to find T2. So then complete the free body diagram for the second block. Besides the tension in the string holding it up, there's its weight, which is mg. So in this case, it's 2 kilograms times 10 meters per second squared, 2 times 10, 20 newtons. So then, again, it's not accelerating. That means the net force on it has to be 0. That means that the tension's got to be the same as the weight of the block. So the tension in the second block is 20 newtons. All right? But that makes sense. The tension in this first string up here has got to be greater because that first string is supporting both blocks. The second string is only supporting the second block, so there's less tension in that string. And so there you go. Blocks and strings and acceleration in Newton's second law. So that's good for this one.